GATE 2018 Civil Engineering Set 1 Question 50. In a laboratory, a flow experiment is performed over a hydraulic structure. The measured values of discharge and velocity are 0.05 meter cube per second and 0.25 meter per second respectively. If the full-scale structure 30 times bigger is subjected to a discharge of 270 meter cube per second, then the time scale model to full-scale value up to 2 decimal places needs to be found. The relevant NPTEL reference has been cited. Coming to the useful data, for model testing in engineering, we use the concept of similarity. So usually there are different concepts of similarity that are used. The first one is geometric similarity. Here we use the length scale that should be similar for both the model and prototype. Another concept is kinematic similarity, where we use the length scale along with the time scale. The third one is dynamic similarity, where we use length, time and force scales together to compare the model and prototype. Another concept is the thermal similarity, which is used in some cases. So depending upon the application, different kinds of similarity concepts are used for comparing the model and prototype. In our case, we have been given the discharge of the model as 0.05 meter cube per second. The discharge in the prototype is given as 270 meter cube per second. The length scale indicated by LR, which is the length ratio, is given as 1/30, which will be the length of the model divided by the length of the prototype. So the discharge ratio is given as the ratio of the discharge of model to the discharge of the prototype, which would be 0.05 as given here and divided by 270. This would give the value to be around 1/5400. This is our discharge ratio. Discharge ratio can also be written as the L cube over time for the model divided by the L cube by time for the prototype, as discharge is nothing but meter cube per second, which is length cube by time dimension. So we have used this here to find the discharge ratio in another terms. This can be further written as length of the model by length of the prototype cubed into time of the prototype by time of the model. This can be written as we saw here, Qm by Qp is given as Qr. So similarly, length of the model by length of the prototype is the length ratio. So this can be written as Lr cube into Tp by Tm can be written as 1 over the time ratio, where Tr will be Tm by Tp. So comparing 1 and 2, as the left hand sides are similar, we get Lr cube over Tr equals 1/5400. We need to find the time ratio, which will be Tr equals 5400 into Lr cube, which will be 5400 into Lr here is given as 1/30 in the question, as the prototype is 30 times bigger than the model. Substituting the value, we will get the time scale as 0.2. So the time scale value for the model was found out to be 0.2. The relevant NPTEL reference has been cited.